they want me to write the equation for this, and it gives me a hint for transformations. Now, so I can tell shifted to the right and shifted up. It's been reflected, so it's, you know, opening down instead of opening up. And it does not look like it's the same size as the parent function. The parent function, remember, goes over 1, down 1, over 1, down 1, and it goes over 1, down 1 the other way. So the parent function would look like this. So this looks like to me that it's wider. Remember, wider is a outcome of getting shorter. So it looks like to me I'm going to have a compression. So it's opening upside down, so I know A is negative. It's not going over 1, down 1. Instead, it's going over 2, down 1. And it looked like it went over 2, down 1 to me on both sides. So it went over 2, down 1. So since it is going over 2, down 1, that means it got shorter. I had to go over twice as far. So it's a compression of 1/2. And you can even do it as rise over run, rise over run. That's what the new rise and run is. So A is negative 1/2. Here's the vertex right here. The vertex is at 7, 2. So this is the value of H. This is the value of K. So H is 7. A is 2, so I'm ready to write my equation. It's y or f of x or g of x or whatever the name of the function is a, which is negative 1/2, absolute value, x minus, that's part of the formula, x minus h, and then plus k. And of course you could go and check your answer on the calculator. All you'd have to do is go over to a graphs page, do tab, let's delete that off, and then put in negative 1/2, whoops, I didn't do the divide, negative 1/2, and do the absolute value, and then do x minus 7, get outside the absolute value bars, hit it before I was ready, and then press enter. And you can see right there, there's the vertex. It may help you see that it's the right graph, and then again it may not. It might help if you can change the window to be exactly like this one. Make it be negative 4 and 10 and negative 6 and 6. So I could make the window be, what I say, negative 4 and 10. And then on the y it was negative 6 and 6. That may help it look a little bit more like what you're trying to match. So the end behavior, oh my goodness, I have a misspelled word right there. That should be each of the following for the given graph. Write the end behavior. The end behavior on the left side here, this is x approaches infinity, because negative infinity, because I'm on the left. What's my y doing? My y is also going to negative infinity. What's it doing over here as x approaches positive infinity? What's my y value doing? My y value is going to negative infinity. So these two things right here would be the answer. Find the vertex. We've already done that. The vertex is at 7, 2. How many x-intercepts does this have? Don't fall prey to this silly thing right here. We know that this thing keeps going, so somewhere over here it is going to cross the x-axis again, so it's going to have 2. And then what is the range? We've got arrows going in each direction, going down, so we know that the range starts at negative infinity. And then as we move up the y-axis, we see that the highest point right there happens at 2. It is a solid graph, so I am going to include the 2, and then this is how you write it in interval notation. And if I ask you for inequality notation, you would say y because it's range. You would put the 2, and then you would tell me that it's all the values less than 2. Write the description of the transformations. That is a vertical compression or shrink. You could put shrink by a factor of 1/2. That means that each one of your y values got half as tall. It is a horizontal horizontal shift, horizontal shift, 3 units. Be careful here to the left because h is -3 in this case, because while we see a plus sign, k is +1, so it's a vertical shift. 1 unit up. Okay. Write an absolute value equation with these parameters, reflection over the x-axis. So these 2 things right here give me the value of A. A is negative because of this one, and it's a vertical stretch by a factor of 5. Horizontal left, so that means h is -2, and this means k, it's going down, so k is -3. So y equals -5, absolute value x minus a -2. So I'm going to put x plus 2 and then -3. Okay, so it looks like these are all the exact same thing. They all have a vertex at -3, 2. They all have a vertex at -3, 2. So that means they're all going to be x plus 3 plus 2. That's going to be the absolute value bars part. They're all over 1 up 1 on both sides. So my A is a 1, so I don't have to worry about that. And all I'm going to have different on each one of these is going to be which symbol is between the y and the absolute value part. So I'm going to have y right here, and then which symbol is going to go there. Where did I shade? First of all, it's solid, so you know it's going to have a bar underneath it. And I shaded below my absolute value bars. Below is less than. Okay, I'm not going to have a bar. So where did I shade? I shaded below. Below is less than. Okay, have a Y. It's not going to have a bar because it's dotted. Where did I shade? I shaded above. Okay, it's going to have a bar because it's a solid graph. And where did I shade? I shaded above. So it's greater than. So that's the only difference in each one of those is which inequality symbol goes there.